Hello class. So today I want to go over a solving exponential equations problem. They tend to be a little tricky algebraically, and then also I think they're a little new in terms of how you're going to manipulate some of the stuff that you're going to deal with. So what I want to do is we're going to solve this problem together. Once we get to a step that I normally find students have a hard time with, we're going to kind of copy the algebraic techniques that you utilize when you're doing a simpler looking problem. So that way you can kind of compare and see how you're really doing the same thing. It's just with an exponential equation it looks a little more complicated. So when you're dealing with an exponential equation, first you're going to know that you're dealing with one when you see that the exponents have variables on top of them. So like for example here, 11 is the base, but our exponent has a variable, and 7 is the base, and it has the variable x. Now, sometimes you can convert one side of the equation by manipulating the base so that it looks like the other one. But in this case, we're not going to be able to do that. And when that happens, what you want to do is your goal is to isolate the variable x, but because it's an exponent, we want to bring it down. And the tool to do that is you want to kind of undo the exponent, and the inverse of that are logarithms. So whenever you're solving an exponential equation, most of the time you're going to want to introduce a logarithm, and then vice versa. If you're dealing with a logarithm equation, you're probably going to want to introduce exponents to undo them. So in this case, we do want to start off. Notice that both of these are equal to themselves. And if two expressions are equal to themselves, and you take the natural log of one side and take the natural log of the other side, since they're equal to themselves, the natural logs of them are also equal to themselves. So because these two things they're claimed to be equal, you could take either the natural log of both of them or any kind of log as long as it's the same base. So let's go ahead and take the natural log of both sides. So since this is equal to this, the natural log of those two things are also equal to themselves. Okay? And from here, now we're going to be able to apply the power rule, because we have that, for example, ln of 7 to the x. Now I'm going to be able to drop down the x and multiply it, and drop down this power and multiply it here. So then what we end up with is, remember the power rule, the exponent will now be multiplying with the natural log of the base that you originally had. And then here, this exponent is going to multiply with the natural log of 7. So let's just note that down. So to go from here to here, what we did is we applied the power rule of logs. Okay? And that notice that now, by introducing logs and applying one of its rules, we now are able to get rid of exponents. And now we just are dealing with multiplication and addition. Once you get here, I usually find that it's at this step, the algebra involved in this upcoming stuff, that tends to be a little confusing for students. So what I would like to do is I kind of want to show you guys an analogous problem that looks very similar to it, that's a little bit easier for students to understand. So for example, notice that this expression is multiplying the natural log of 11. And then just go back and remember what a natural log was. Remember that natural log means that you're taking the log base e of 11. And if you were to plug the natural log of 11 in a calculator, you're going to get a nasty decimal. That's the decimal that e raised to that decimal is going to give you 11. And then on this side, if you enter the natural log of 7 on the calculator, you're going to get a different decimal, because that's the different decimal that you're going to raise e to get 7. Okay? But what I just want you guys to remember, and students usually, the notation's a little nasty, this is just a number. It's just, not a nice looking decimal number, so we write it in math in this format. But this is just x times a number, and this is 2x plus 3 times a number. Okay? So if we were to copy that, but let's just change this equation so that it looks like this. And let's say we have just the number 11, and then x times 7, we don't write it like that. We write it like this, right? But in natural log format, we do put the variable in the front and then leave this on the right side. So here we have x times the number and 2x plus 3 times the number. Just the way we do here, it's just that the numbers are different, okay? But in this format, I think you're a little more used to seeing this one, and you're probably already seeing, oh, here, to start solving this equation, I have to distribute the 11, the number, with the expressions on here, and to do that, then you would multiply, now you would multiply in your head 2x times 11, and plus 3 times 11, and then you would just write, you would actually multiply the 2 with the 11 and do 22x plus 33, and then on this side you just leave it the same, right? But it's this algebraic step that you're used to doing is distribution, right? And then you know that these have to be multiplied. So we're going to apply the exact same step on this over here because this is just a number multiplying this expression. So you're going to distribute it with the 2x and with the 3. And just the way your brain is multiplying these with the number that you distribute, we're going to do the same thing, but the format and how you write it is a little different. So here we're going to write it as 2x times the natural log of 11, and then plus 3 times the natural log of 11. But we write it right next to each other like this, right? And then the difference, though, is that here you're actually able to just multiply the 2 with the 11 and get 22. But on this format, remember, this is not 11. It's the natural log of 11. It's some other totally different number. So you can't just multiply the 2 with the 11 like that and get ln of 22. You can't do that, okay? So we just write it side by side multiplying. And the 3 does not multiply with the 11 again. It's multiplying with the natural log of 11. It's some nasty decimal number. But we're going to write it like that, side by side. And then on this side, we just leave what we already had. Okay. And then from here, this is also very confusing to students. But when you see it on this side, it's not so confusing. Remember that when you're solving for x, if one side of the equation has an x and then the other side has an x, you want to bring all of the terms that have x's on one side. So we want to bring this 7 to the left, and then anything that's a constant, we want to put it on the other side. So algebraically, you would subtract the 7x and subtract it on the left side so that we can cancel it off. But then that constant, you would also want to move it to the other side. So we would minus the 33 and put it on the right side. So that algebraic step that we did is exactly what we're going to do here. Notice that this has an x and this has an x. And this term is just a constant because it has no x's and it's just a number, right? So just the way you subtracted the 7x on this side, we're going to subtract this term on and bring it to the left-hand side. So we're going to do minus x ln of 7, and then minus x ln of 7. It'll cancel off on this side. And then just the way we wanted to move the 33 on the other side by subtracting it off, we're going to subtract 3 ln of 11 and minus 3 ln of 11, like that. Now it cancels off, just the way this would cancel off. Now here's where this now becomes very different in terms of format and how you write it compared to this easier problem. Here, you would actually go ahead and just subtract the 22 with the 7, but here we're not allowed to subtract these like this, okay? It's not as easy. But what your brain is doing is that it's going 22x minus 7x, right? This has been canceled off. This has been canceled off, and you end up with a minus 33 on this side. And then, so notice that just the way we can write it vertically, you can write it horizontally, and I'm really going step by step. So I can do the same thing here. Because it's not as easy to subtract these two terms with x's, and I know this canceled off, I'm just going to write this subtraction horizontally, and do 2x ln of 11 minus x ln of 7. This cancels off, this cancels off. And then now on this side we're left with minus 3 ln of 11. Now the next step is the whole purpose why you move everything with an x on one side. Like I said here, you would go ahead and subtract 22 minus 7. But notice that what we can also do is that these two terms both have an x, so you would be able to factor out the x, and you would end up with x and times 22 minus 7, which is again the 15 that your brain has been doing. And then we just get minus 33. And so we would do the same thing here. These two terms had an x, these two terms both have an x right here. So we're going to factor out the x. So when you factor out the x, you end up with 2 times ln of 11, and then minus ln of 7. Minus ln of 7, like this. And then on this side, we just have our negative 3n of 11, ln of 11. Okay, now let's kind of see, we move on with this side here. Like I said, here you would actually subtract it and get the 15 times the x, so you would get the 15x equaling the minus 33. Here you have x times a number, so you want to isolate the x by dividing off that number. So you would divide the 15 off, do whatever you did on this side, I would do on this side, then it gets canceled off, and then notice that this becomes your answer, right? Because now x is by itself. So we're going to copy that same strategy here. This is all just a really big, nasty, ugly decimal number that's being multiplied to 11. So just the way you divide the 15 off, we're going to divide off this nasty looking number to both sides. So I'm going to divide this by 2 ln of 11 minus ln of 7. And whatever I do on one side, I have to do to this side. So divide off 2 ln of 11 minus ln of 7. This gets canceled off, this gets canceled off. So this expression ends up being your answer. Just the way this ends up being your answer. So minus 3 ln of 11 over 2 ln of 11 minus ln of 7. And just the way you can normally simplify a fraction, here you could also technically simplify all this. This minus 11 here, and this 2, you can reverse the power rule to bring the 2 up if you want. And then with the minus, you can use the quotient rule and write it as a division inside of the ln. You could simplify it a lot, but that's okay. This is fine as an answer. If this homework question is asking you to round to say the nearest 10th decimal, you would then just write this expression in your calculator, calculate that decimal, and just round it to the nearest 10th decimal place, okay? So this is the nasty looking number that when you input here and input here, both sides are going to be equal. So don't ever forget what you're doing. But in this case, this is our answer right here. So I hope you found this helpful. Like I said, this is the algebra that students tend to kind of get a little uncomfortable with. But remember, you've been doing it. It's just that it looks different because of the natural logs, okay? Have a great rest of your day. Thank you.